Wow, full room. Thank you guys for coming. This is Advanced SQL Server on vSphere Techniques and Best Practices. I'm hoping that you're enjoying Barcelona and VMworld in general, and I hope I can make it worth it to you to sit so close together. Just a quick introduction. My name is Scott Salyer. I joined VMware in May of 2007, so I've been around for a long time. Myself and my group pioneered virtualizing business-critical apps back then. The company told us, oh, you can't virtualize mission-critical apps or Tier 1 apps. It's really too risky. We shouldn't push customers to do it. And now look where we are. We have so many workloads, high-end workloads, that are being virtualized. So what this deck is about is tuning best practices all the way from the storage layer to the ESX layer up to the virtual machine itself. So we'll walk through performance, we'll walk through database consolidation, and then we'll follow up with SQL Server availability. So let's move on. There are a lot of technical slides in here. We have like 60 slides, so I'll try not to rush. There are a lot of words on the slides too, and I'll tell you, a lot of our customers and partners use this as reference material, so hopefully you'll find it to be useful in the same way. So a few quick facts. We got this from our internal database called Capacity Planner, and what we noticed that our customers are typically showing about 10% of their workloads are SQL Server. And out of that 10%, most are typically underutilized, between 6 and 20%. Now, we do have, obviously, high-end SQL servers that are running at 60, 70, 80, 90% utilization, but the vast majority of SQL servers are fairly small instances and fairly underutilized. Many DBAs are hesitant to virtualize because they perceive issues with performance and availability and licensing, and in some cases, support. We'd like to dispel some of those myths today, but how many DBAs do we have in the audience? And database administrators? We're getting more and more every year, yeah. Great. So one thing to consider is running SQL Server workloads on vSphere can help you reduce your physical server footprint through consolidation, can help reduce your licensing costs, and can increase your availability without sacrificing performance. In addition, for the DBAs out there, the SDDC platform, the VMware SDDC platform, offers management benefits that help you as an administrator, such as in-depth application monitoring with vCops, automation provisioning of databases with vCAC and vCenter Orchestrator, and then application and site resiliency with Site Recovery Manager. So why would you deploy databases on VMware SDDC? Reduce licensing costs. That's probably the #1 reason. And that dovetails into database consolidation, which will allow you to reduce hardware costs by up to 50%, depending on your consolidation ratio. With our orchestration products, you can provision databases on demand and even set up a developer self-service scenario where developers are provisioning their own database instances. Increase application quality of service. You can scale dynamically. You can protect with high availability and disaster recovery, and then complete isolation between systems on the same host, so enhanced security. For the DBA, we simplify many of your DBA tasks, as I mentioned before, from design, capacity planning, to installation configuration, to backup and recovery, all the way to troubleshooting and support. The VMware SDDC suite can help you accomplish those things easier and more time efficiently. Now let's get into the real meat of the presentation, and that's designing for performance. And keep in mind, this is for Tier 1 production workloads. You don't need to do this for every SQL server out there because most of them are small and most of them are underutilized. So keep the context of Tier 1 production workloads in mind as we talk about designing for performance. Now here, this might help you later, but I kind of summarized all the best practices into an agenda slide that we'll keep going back to. I'm going to start with the bottom, the storage layer, and tell you what needs to be done at the storage layer to ensure performance. Then we're going to move up to the ESX server and talk about things like memory management, large pages, avoiding host swapping. And then when we get to the guest itself, we'll look at Windows and SQL Server tuning parameters. So a real quick summary. We recommend that you design for performance in addition to capacity. And we'll explain all this in depth later. We recommend dedicated data stores for performance critical workloads. We recommend that you avoid lazy zeroing and that you pre-test your workload types before deploying. So let's go a little bit deeper into that. One of the biggest mistakes folks make when designing a database is to design for capacity, but not necessarily performance. And performance in a storage array, well, in a magnetic disk storage array, is typically spindle count. So spindle count still matters. But the end result is that you want to get the right amount of I/O to the VM. If you look at the entire host, the spindles required to support that, or the I/O required, is an aggregate of all the virtual machines on that host. Now, you don't have to go into actually counting spindles. As long as your LUNs can give the I/O to the VM that it needs, you've accomplished your goal. But don't ignore spindle count. It is definitely something to look at. For data stores, be sure that you work with your storage engineer very early in your design process. We recommend dedicated data stores for BCA workloads, and that can occur in two ways. You can either create an RDM and dedicate it to that VM, or you can create a VMDK file and put it on a VMFS volume by itself so that there's no contention with other workloads. Of course, you can always use storage vMotion to balance workloads across data stores. We recommend that you load balance your workloads across as many disk spindles as possible to get the highest amount of performance. And now it's a cost-performance trade-off. Obviously, you want the best performance, but you don't want to be wasteful. Be sure to follow storage vendors' best practices. Make sure that you set a minimum of 4 paths from the ESXi server to the storage array, which requires at least 2 HBA ports. A few more bullets. Make sure that your storage adapter cards are installed in slots that have enough bandwidth to support the workload. Make sure that the appropriate read-write controller cache is enabled. And configure maximum queue depth if needed on fiber channel HBA cards. And there are a couple of links there that will show you what those queue depths should be. So VMFS or RDM. This used to be a big difference. It's no longer as big of a difference as it used to be. From a performance perspective, if you have one VMDK on one VMFS volume, you'll get roughly the same performance as a dedicated RDM or a raw one. And then with vSphere 5.5, we support up to 62 terabyte VMDK files. So size is no longer a problem for VMFS volumes. So really, when should you use raw device mapping? If you're doing legacy failover clustering with shared disk, a shared quorum disk, then RDMs are required for those volumes. And some storage vendors and SAN management tools around backups and snapshots require raw device maps in order to work properly. Otherwise, well, we recommend you use VMFS. You really get the best set of features for your databases. Now, VMDK lazy zeroing, and I'll point you to the blue. If your storage array does not support VAAI integration, then follow these best practices. If it does, then VAAI will improve your zeroing in supported arrays. So what we're talking about here is when we lay out a VMFS volume and put down a VMDK file, we do not, by default, zero out the blocks. So when I go to write to that block from the SQL Server, I have to zero it, and then I get to write to the block. It's called a first write penalty. You can avoid the first write penalty by formatting your VMDK as eager zeroed thick. And there are a couple of ways to do that. In vSphere 4, I don't know how many of you are on vSphere 4, but you were to check support clustering features such as fault tolerance. That turned on eager zeroed thick. Or in vSphere 5, there's an option button called thick provision eager zeroed, and that will allow you to pre-zero those blocks. You can also do it from within the VM by not doing a quick format. So where it says perform quick format, uncheck that. Do a full format, and that will automatically zero the blocks for you as well. Be sure and understand your workload. You can fit a lot of stuff onto a VM, but if you fit too much, it's not going to perform well. So let's look at different database workload types. And later on, when we talk about consolidation, this will make a difference in how you stack VMs on a particular ESX host. So OLTP, or online transaction processing, is probably the most common workload. It's large amounts of small queries. During working hours, you typically see sustained CPU utilization, and that drops off when everyone goes home from work. And it's sensitive to peak contentions. Then you've got your batch or ETL workloads, which are generally write-intensive. They generally run off-peak hours and have low CPU utilization during normal working hours. And then decision support or DSS workloads, small amount of large queries, and are typically seen at the end of the month or whenever the company does a lot of reporting against the databases. So here are some of the characteristics of some of these workload types. So for instance, OLTP log is sequential and is write intensive. OLTP data is typically random and both read-write, and then you can see the rest. The best thing to do is to take a look at your particular workload, figure out which category this falls in, and then test with a tool like SQL IO-Sim or Iometer to make sure that your VM can stand up to the workloads you're planning to put against it. And there's some sample patterns to test. For instance, typical OLTP data files are 80% read, 20% write. So just to summarize storage, designed for performance and not just capacity. Use eager zeroed thick if you're not using a VAAI compliant array. Make sure that your blocks are aligned at both the ESX and Windows levels. I've got a slide on that later to show that block alignment. Make sure you understand your I/O requirements and always, always, always test before you deploy into production. A general rule of thumb, it's not a requirement, but a general rule of thumb is smaller LUNs are better for manageability and performance. Be sure if you're using iSCSI or NFS that you optimize your IP network for that, and make sure that you use multiple vSCSI adapters within the VM in order to evenly distribute to target devices. So moving on to the ESXi layer, again, we're going to reiterate, because we're kind of crossing between storage and ESXi, but I'm going to reiterate multiple paths to the storage array with a minimum of at least 2 HBAs. A couple things that we do around memory management or recommend. We recommend to use large pages at both the host and the guest. Do everything you can to avoid host level swapping. Optimize any network for IP-based storage protocols, and be sure and design with NUMA in mind, and use virtual NUMA to extend to the guest. So I'll drill down on each of these in the slides to come. So ESXi large pages. By using ESXi large pages, you end up avoiding TLB misses, transaction look-aside buffer misses, which means that your application is going to be more responsive. The other good thing about large pages is that ESX will not share large pages unless there is memory pressure. Now, for systems with hardware-assisted virtualization, we also recommend to use guest-level large memory pages. And ESXi will use large pages to back the guest operating system memory pages even if the guest operating system doesn't take advantage of those memory pages. So yeah, keep that in mind. The best advantage is large pages typically do not swap. What ESX will do instead of swapping a large page is it's a lot less overhead to break that large page into smaller pages first before swapping them to disk. So this is one, by using large pages, those pages are the least likely to swap to disk and the least likely to be hit by performance or be impacted from a performance perspective. Swapping is very bad. Swapping is the worst thing that can happen on an ESX server. Swapping happens when the ESX host is trying to service more memory than it physically has, and the memory optimization features such as transparent page sharing and ballooning are insufficient to provide relief. And swapping can occur in two places, at the guest OS level and at the ESXi level. There's very little you can do about swapping in the guest, but at the ESXi level, you can pretty much eliminate swapping if you design correctly. The bad thing about swapping is it slows down not only the VM that you're running, but all the other VMs that happen to be on that storage volume. So two ways to keep swapping from affecting your workload. At the VM level, you can set your memory reservation to equal the allocated memory. So if you've allocated 32 gigabytes, then reserve 32 gigabytes. At the host level, we recommend that you do not overcommit memory until you show that steady state usage is less than the amount of RAM on the server. The other thing you can do is don't disable the memory management features that help you avoid swapping. Transparent page sharing is a way that ESX can share memory pages across workloads, across VMs that are identical in order to reduce the overall memory used by the host. It has very low overhead. And it kicks in, transparent page sharing kicks in as that little bit extra to help you avoid disk swapping. Now, ballooning is kind of controversial for high-end workloads. We've heard some customers say that they're afraid of ballooning and what it will do to their workloads. Ballooning basically lets the ESXi host borrow memory from one VM and give it to another. So the way this happens is the host exerts memory pressure into the VM. So to the VM, it looks like that memory is being used. It grabs that memory and gives it to another VM that is in need of it. This is the host's last option before swapping. So you definitely want to keep this on. Even though ballooning will decrease performance slightly, it will decrease performance less than swapping. So you always want to leave it in place. If you don't overcommit on the host, you'll never have to worry about any of this. This is only when you overcommit resources at the host level. So memory reservations are a way that you can guarantee your most important VMs get the resources that they need. If you have strict admissions set, the VM will not even be able to power on if the CPU and memory reservation are not available. So definitely keep that in mind. If you can't power a VM on and you set a reservation, that's typically why. Even under heavy loads, the reservation wins. So if you have 6 VMs on a host and you reserved for one, every other VM on the host could be starved for memory, but the one you've reserved memory for will always run the same. If you set your reservation to equal the size of the configured memory, remember the 32 gigabyte scenario. If I have 32 gigabytes assigned to the VM and I reserve 32 gigabytes, I have a 0K swap file, which means that that VM will never swap to disk. Moving on to networking, a few networking best practices. We typically recommend separate NICs for vMotion, FT logging, and ESXi console management traffic. The other way of going about that is to use VLAN trunking to separate that traffic. vSphere 5 introduced the ability to vMotion using more than one NIC. So that allows more simultaneous vMotions. Be sure to use NIC load teaming. and have a minimum of 4 NICs per host, so you ensure performance and redundancy of the network. Most NICs support these things, but at the bottom, we recommend NICs that support checksum offload, jumbo frames, and a couple of other features. The first bullet here is somewhat controversial. It really depends on your licensing strategy. If you mix all your SQL workloads up with other workloads, then the recommendation is that that you separate workloads with chatty network traffic like Microsoft AlwaysOn from ones with chunky access. If you're consolidating your licensing by host, typically you're going to put all your SQL servers in one cluster anyway. So use that one as you need it. Use distributed virtual switches to increase networking convenience. I mentioned optimizing IP-based storage. So you definitely want to enable jumbo frames for any IP-based storage. Use a dedicated VLAN for the host VMK NIC and iSCSI NFS server to minimize network interference from other packet sources. What that basically means is if I have storage going out one pipe, I don't want other types of IP going on that pipe. I want that to all be storage. Also use the VMXNet3 paravirtualized driver to increase performance. It reduces overhead compared to the other adapter drivers, and you must have VMware tools in order to turn on VMXNet3. When you're using jumbo frames, you need to make sure that jumbo frames are configured at the ESX level and then all through the network, at the switch level and the router level, in order to take advantage of that. If one of the stops in this picture are not enabled with jumbo frames, you can't use jumbo frames. It has to be done all the way through the stack. If you have issues with always-on availability groups with cluster failovers, sometimes it's a good idea to set some of these parameters, these heartbeat parameters, to a little higher than they are by default. We recommend a cross-subnet delay of 1,000 milliseconds and same subnet delay of 1,000 milliseconds. This will, if you find that you're seeing random cluster failovers, this is an option that can eliminate that. NUMA. So NUMA really is designed to avoid a performance hit when several processors attempt to access the same memory. So what we do here, or the science behind this, is that the processor has a bank of memory that's dedicated to that processor. It's really good if a workload fits within a particular NUMA node. But if a thread, say, in the upper left-hand corner needs to access a memory node in the bottom right-hand corner, that's called NUMA crosstalk. And NUMA crosstalk can drastically impact performance. So we have a few best practices around NUMA. So first of all, we have virtual NUMA in vSphere 5. And this extends NUMA awareness to the guest operating system. Some applications can take advantage of that, some can't. But in the case of SQL Server, it can take advantage of the NUMA awareness. It is enabled through the multi-core UI. We have a screenshot to the right. If you create a brand new VM with 8 vCPUs or more, this is turned on by default. Existing VMs that are migrated from an older environment and brought up to, say, vSphere 5 or 5.5 are not affected through the upgrade. So you may have to go in and turn it on for those large VMs. For smaller VMs, you can enable by setting the numa.vcpu.min equals 4. Now, NUMA, virtual NUMA does not work with CPU hot add. They are incompatible. So make sure that you turn off CPU hot add in order to enable virtual NUMA and vice versa. When we talk about wide virtual machines, that's virtual machines that are larger or span more than one NUMA node. We recommend that this feature be on for best performance. SQL Server will automatically detect the NUMA architecture and optimize the workload for that NUMA architecture. There's a great, really, really great paper on NUMA listed at the top there. I would recommend that you read that. You may have to read it 3 or 4 times. It's pretty deep. But definitely recommend that you take a look at how NUMA works in ESXi. Be sure to avoid remote NUMA access. So if you can, the number of vCPUs should be less than or equal to the number of cores in the NUMA node. That's for best performance. Now, that's not always practical. So for wider VMs, then that's why we implemented the virtual NUMA feature. When it comes to hyperthreading, we recommend that, if you're just dipping your toe into Tier 1 app virtualization, if you're just getting started, that you be conservative and set the number of vCPUs equal to the number of cores. Hyperthreading really only gives you about a 20 to 25% benefit. There are some cases where hyperthreading will really help a workload. There are some cases where it really won't. VMware or ESX by default, if there is a free core available, a full core, versus a hyperthread available, by default ESX will run that workload against a full core because it's going to give you more performance than a hyperthread. If you don't want ESX to act that way, there is a numa.vcpu.preferHT option that you can set, which will prefer a hyperthread over a full core. That is on a case-by-case basis and depending on the workload. For the vast majority, though, it's typically better just to go one-to-one. Be sure to align VMs with physical NUMA boundaries, as we talked about before. Use ESX top if you want to monitor NUMA performance at the vSphere level. And the last bullet point is important. If you vMotion, be sure that you move between hosts with the same NUMA architecture, or you could get a performance hit until the reboot. So if I have four sockets with 4 cores per socket on one box, and I have 8 sockets with 4 cores per socket on another box, then that's a different, well, sorry, it would be maybe 6 cores per socket. So you have 8 cores per socket over here, 6 cores per socket over here, then NUMA is suddenly dead in the water until, or NUMA optimization, until you reboot the VM. Now, last but not least, we'll take a look at the guest and how to tune performance within the guest. PVSCSI Adapters. PVSCSI Adapters are the latest and most advanced SCSI controller drivers. They are recommended for workloads that have high performance requirements. They have larger queue depth per device and per adapter, and less CPU overhead than any other storage controller driver. It does require VMware tools just like the VMXNet 3 driver. They cannot be used for the OS partition. Typically, you need to use another protocol there. And we recommend that you increase the queue depth within the Windows guest OS by taking a look at this registry setting. If you're using any type of clustering, shared disk, non-shared disk, whatever the case, PVSCSI adapters don't work for that, or not supported. When looking at NFS, in-guest iSCSI and vSCSI adapters, around NFS, it is supported for SQL Server, but is not supported for Windows failover clustering. For the in-guest iSCSI option, it's supported for both standalone and clustered VMs. We don't mandate any considerations about software-based iSCSI. One good thing about in-guest iSCSI is that it will allow you to vMotion even if you're using RDMs. It's not a supported configuration, but it is something that can be done. So let's summarize some best practices around memory management, and then we'll kind of delve a little bit deeper into these. Really the best way to avoid memory performance problems is to avoid overcommitment of memory at the host level. Now, that's the most basic and best way to get around swapping and poor performance and that sort of thing. If you have to overcommit, then prioritize your VMs and protect the most important ones with reservations. We recommend that you size the VM to avoid NUMA remote memory access, to size the VM less than or equal to the memory per NUMA node if possible. Also, you should use large pages within the guest, and that requires a privilege called lock pages in memory, a write. Lock pages in memory write for the SQL Server service account. If you're consolidating multiple instances of SQL Server onto the same VM, we recommend that you control those instances using some combination of max server memory and min server memory within the SQL Server environment. And then, of course, goes without saying, disable any unnecessary processes in Windows. So we mentioned using large pages in the guest, and this is in SQL Server Configuration Manager. You go into the startup parameters and you add the trace flag -T834. This enables large pages within the guest. But that's not all you do. In order to get it to work, you need to give the SQL Server service account lock pages in memory user right. A few considerations for CPU sizing. Understand your existing workload, understand your average and your peak, and consider any future growth. For tier 1 workloads, just like memory, avoid overcommitment. For lower tiered database workloads, overcommit depending on the utilization of the VMs running. If VMs are running at 50% utilization, you can overcommit by a factor of 2 to 1. If they're running at 25%, you can overcommit by a factor of 4 to 1. It really depends on what the utilization of those VMs would be. A certain level of overcommitment can really pay off in license savings, especially if your workloads are typically underutilized. No matter what, always monitor. Monitor at the host level, percent ready, percent MLMTD, and percent co-stop. At the virtual machine level, you want to monitor the processor queue length. We've talked about NUMA enough, so the NUMA rules for CPU are the same as they are for memory. Try to keep them within a NUMA node or use virtual NUMA if not. Be aware of hyperthreading. It does not provide the full capability of a full core. It's typically only a 20 to 25% increase, and it's typically harder to manage than one-to-one core mappings. In a high-performance environment, once the host CPU utilization exceeds 65%, consider moving some of the VMs off to another host. Turn off all power-saving features, and then use vCenter operations to monitor consumption and to give you capacity metrics. Okay, moving on to storage. There's some storage best practices for SQL Server on TechNet. Always want to take a look at those. We recommend that you pre-allocate your data files so that you can avoid auto-grow during peak time. So if you know your database is going to be 100 gigabytes, then pre-allocate that data file beforehand. Auto-grow can actually cause a performance hit every time the database grows a little larger. We also recommend that if you use auto growth, that you should use megabytes and not percent. The calculation is easier for SQL Server going by megabytes. Be sure and use multiple data files for data and for tempDB. The typical recommendation is 1 file per CPU core. Now, multiple tempDB files can coexist on the same volume, but it's typically not encouraged. You're welcome to research that yourself, but 1 file per CPU core is typically a best practice. If you have tiered storage, then the best way to place your files are transaction log files go on the fastest storage, Your temp DB data files go on the second fastest, and your data files go on the third fastest. Place data and log files on separate LUNs for maximum performance. Be sure and perform routine maintenance on your database. Again, number of data files should also be number of processor cores. And always be sure and use multiple vSCSI adapters in the guest. You can use up to 4, and that'll spread the workload across multiple software controllers. Now finally, block alignment. We recommend that you do this at the ESX host level and at the guest level. So at the ESX host level, be sure that you create your disk from within the vCenter client to get those aligned at the host level. And then at the guest level, we recommend that you check to see if the server is aligned once you've added all the disks. One example, Windows 2008 and above is supposed to automatically align the disks for you. But imagine a scenario where I create a template with just an operating system drive, and then I add on the data and log drives later. Those data and log drives may not be aligned. So once you add those, go back and check and make sure that the blocks are aligned from within Windows. We've seen as much as a 30% performance hit from block alignment problems. So even though Microsoft says it's supposed to be automatically done, check it. Did you want to take? Please go ahead. All right. So consolidating multiple workloads. Up to this point, we've been basically talking about, high performance VMs, but there are scenarios where you might want to take those and stack multiple VMs on an ESX host for consolidation reasons, for licensing reasons, ease of management and administration. So there's a couple methodologies you can take here. You can use the scale-up approach. The scale-up approach takes a VM with Windows and runs multiple SQL Server instances inside that VM. This is good because it allows fewer virtual machines. But it's much more difficult to manage workload in this situation. You have to be really careful with your min server, max server memory settings. But if you're pretty comfortable with that and pretty familiar with that, you could potentially reduce the amount of SQL Server licensing. For instance, if you're licensing by VM and not by host, this might be a good way to go. The scale-out approach is a single database instance per VM. It has potential to increase your management overheads because you have more VMs. But it gives you better isolation and better performance and better ways to control the performance of each database. DRS is typically more effective with small VMs as well. vMotion, DRS, all of that. So with smaller VMs, it's more likely that if you need to move a workload to another host, it's more likely to find enough processor and memory to run that VM versus a giant VM that it's got to look all over the environment to try to find a spot for. And you get faster vMotion. It's really up to you. A lot of DBAs would go for the scale-up approach. A lot of VMware administrators would go for the scale-out approach. You guys can fight it out. I think this slide is really interesting because it shows that you can't go by average processor utilization when consolidating workloads. Both of these workloads show 15% CPU utilization. But you can see the OLTP workload between the hours of 7 and 19 are running pretty solid. And then we look at the batch workload, which typically runs at night and is completely unused during the day. So what we say is these types of workloads are perfect for consolidation with each other on the same host. So what you get is better server utilization, improved consolidation ratios, less equipment to patch, and better licensing. Not to mention, since the workloads are running at opposite times, you're not going to affect, or the contention is not going to affect performance of either one. So running with mixed workloads, a couple of considerations. Be sure to manage physical CPU overcommitment as a function of utilization. Always keep that in mind. And batch and ETL workloads with different peak periods mix well together. OLTP typically mixes well with batch or DSS. Just kind of keep in mind the workload when you're designing your clusters. You should also consider that it may not be a daily change, but a monthly or quarterly spike in performance need. So consider month-end and quarter-end as special times where you may have to scale out to more ESXi servers. If it's just a matter of tuning the guest, you can use CPU and memory hot add to quickly give more memory and CPU to the guest in a crisis. Or you can add more hosts to the cluster and let DRS spread those VMs out across more hosts in that cluster to help with the long-term problem. So a few slides on availability. It's important that you understand what the business expects out of your workload. And I use this all the time. Don't just cluster to be clustering. What does the business care about protecting? What are your recovery time and recovery point requirements? What's your SLA to the business? And how you test and verify? If there's anyone that doesn't understand or know vMotion, DRS, or HA, raise your hand. We're moving on. Okay. So VMware support for Microsoft clustering. This is it's kind of an eye chart, but we have two kinds of clustering. We have shared disk and we have non-shared disk. Shared disk is typical Microsoft failover clustering, SQL Server failover clustering with a shared quorum disk that acts as the tiebreaker. For shared disks, we have a bunch of requirements for how to design those systems. Non-shared disk would include SQL Server AlwaysOn availability groups or Microsoft Exchange database availability groups. These are all done. Replication happens over IP. There's no shared disk component, and therefore no restrictions whatsoever on non-shared disk clusters. So just to summarize, shared disk supported on vSphere with considerations for storage protocol and disk config. Non-shared disk configurations, no different than physical. So if you're thinking about always on availability groups, that's the way to go if you're virtualizing. You get the best of all worlds. So the reason why we have restrictions on shared disk is because of the way it works. What we have here is physical or virtual. This is the way shared disk clustering works. I have one set of storage. I have two nodes. I have an active reservation. When I fail over, the second node takes over the storage. Okay? Because of that active reservation, I can't vMotion. Let's see what are all the restrictions here. So with shared disk clustering, we can support up to a 5-node cluster in vSphere 5.1 and above. Failover cluster nodes can be physical or virtual or any combination. You can cluster a physical with a virtual if you like. We require host-attached fiber channel, FCOE, or in-guest iSCSI. And it only supports raw device maps. So your quorum disk has to be a raw device map. However, this does work with HA. It doesn't work with vMotion, doesn't work with DRS, but it does work with HA. HA is just simply a reboot. So what this can help with is if I lose the host that one of my cluster nodes is on, the database will automatically fail over to the other node in the cluster. In the meantime, vSphere is rebooting the failed cluster node, bringing it back online. It can help shorten the amount of time that the database is in an unprotected state. It also reduces the amount of synchronization time between the VMs. If they're offline for an hour versus offline for 5 minutes, the synchronization time can impact performance, and you want to keep that as low as possible. So the way non-shared disk clustering works, it's a little bit different of a model. I have 2 copies of the data. Each of my nodes owns that copy of the data. And there is a third witness that makes sure that's there to break any ties. So instead of the quorum disk, I have a quorum file share witness. So what happens there is the databases are replicated over IP, and if I lose one, the database fails over to the other copy, which should be up to date because of replication. So if you combine vSphere HA with AlwaysOn, again, the best of all worlds. Seamless integration, supported exactly as on physical. Provides local and remote availability. You can use AlwaysOn to replicate to another site, for instance. Just like before, VMware HA will shorten the amount of time the database is unprotected. So I lose that node. Suddenly I'm limping along on one SQL Server node. Within a couple of minutes, HA brings the failed node back, and I'm synchronizing again. I'm still protected. If you were to do this in a physical world, you are subject to the SLA of your hardware vendor. DRS anti-affinity rules will allow you to avoid running virtual machines that are clustered on the same physical host, because obviously if you lose a host with both of them on there, you've lost everything. And there's a really good study there, SQL Server AlwaysOn running on vSphere 5 with EMC Fast VP. Definitely a good read. I would recommend that you take a look. Now, once you set up your cluster, whether it be AlwaysOn or whether it be shared disk, you want to make sure to use the cluster validation wizard from Microsoft to validate support for your configuration. Run it, actually it says run it before installing AlwaysOn, but I would also run it anytime you make changes. And if you run on non-symmetrical storage, in other words, the arrays are not identical or the LUNs are not identical, then you might need a hotfix from Microsoft in order to support that. Now, I went over this last year in depth, but I'll just barely mention it. One technique that you can use to patch non-clustered databases is to simply, you create a SQL Server standby, you patch it. Once it's up to the correct service pack, you move your data and logs over, and make sure you give it the same name and IP address and power it on. You're now migrated to the newest service pack or patch or whatever the case is without using clustering. If you automate this, the whole process can take as little as 1 minute and 30 seconds. It's a lot cheaper than clustering too. If you want to know exactly how to do this, there's a blog, blogs.vmware.com/apps. It'll tell you exactly how to do this. Oh, and one more plug for this. You have tier 1 production databases. Always cluster. You know, if you availability for those tier 1 databases, cluster or AlwaysOn, we have nothing bad to say about those technologies. For your tier 2, tier 3 databases where clustering isn't necessarily needed, maybe it's a departmental database, maybe it's something that's only used during business hours, this is a way that you can avoid clustering those machines and maybe save a little bit on licensing. So a couple of links. We have a Business Critical Apps website there. Please visit us. If you look at the SQL Server documentation, it's dated 2012, but it came out in 2013. It's for 2012, SQL Server 2012, and vSphere 5.5. So it may look like an older document, but all the best practices are the same. We're doing a refresh for SQL 2014 on vSphere 6, starting in Q1, so definitely take a look out for that. And we're always posting to our applications blog. Definitely recommend you check those out. My colleagues have put out a couple of books. I want to put a shameless plug. Conan Mani and Don Sullivan did a virtualizing Oracle databases on vSphere. Conan works on my team. And then on the virtualizing SQL Server with VMware, we have Michael Corey, Jeff Sastak, and Michael Webster. Definitely real smart guys, so I hope you can pick up their book. And it looks like we have 10 minutes for questions. I'm shocked. So, do we have any questions? Yeah. Do we have microphones or? Okay, a microphone's coming around. We're recording this, so.
You can also repeat the question. How about solid You're talking about number of spindles, how important they are. How about solid-state drives?
I was just talking about this with a colleague earlier. And if you're using a completely flash-based array, then you can design for capacity and not performance. Because your capacity is going to, performance is going to be the same no matter what LUN you build on that. So that's only for magnetic SANs. Okay, any more questions? Thank you, have a good day.
Okay. Hello.